Alright, so we're going to have a look at another question from the 2020 Standard 2 HSC Maths paper. So here we have a question about area and volume. So this is question 25. We're told a composite solid consists of a triangular prism which fits exactly on top of a cube as shown. We need to find the surface area of the composite solid. So note, surface area, not volume. You could be asked volume. Some kids will immediately assume they're after volume. They'll find it, it'll be wrong, and they'll only get something like 1 mark. So read these questions carefully. Surface area. So to find the surface area, we're going to draw a net of this shape. So we have a square on the bottom. The square is 8 by 8, so that's 64 centimeters squared. Then we have 4 sides, one here, one here, one here. This doesn't have to be fantastic drawing, doesn't have to be a Mona Lisa, just has to be identifiable that it is the net of this shape. These are all 64 as well. 64 centimeters squared, 64 centimeters squared, 64 centimeters squared, 64 centimeters squared. Now it gets a little more complicated. The front has a triangle like this. The back has a triangle. The sides don't have triangles though. They now have rectangles. So the rectangles are the flat roof panels and the triangles are the triangular front and the triangular rear. Now the triangles here are a little bit tricky. We're told they sort of look like this. This is 8 and this is 5. Now to find the triangle we need the perpendicular height, which is this height in the middle. So we're going to use Pythagoras theorem to do this. We have this is 5, this is 4. So this side, which we'll call B, we know 5 squared is B squared plus 4 squared. Minus 16 from both sides, 4 squared is 16. This tells us B squared is equal to 9, therefore B is equal to 3. So we know the height of these triangles is 3. So this distance along here is 3. This distance along here is 3. This means their areas are half times base times height. The base of these triangles is 8. 8 times 3 is 24. Half of that is 12. So this is 12 centimeters squared. This is 12 centimeters squared. And then we have the 2 rectangles on the side. Now they are both 5 by 8. We're told in the diagram that these are 5 because these are the same as the hypotenuse of the triangle. 5 by 8 is 40, so this is 40 centimeters squared. This is 40 centimeters squared. And now for the surface area we just need to add this all up. So this implies the surface area is, there's 5 64s, 5 times 64. There are 2 12s and 2 40s, plus 12 times 2 plus 40 times 2. 5 64s, that's 320. 2 12s, that's 24. 2 40s, that's 80. 80 plus 24 is 104. 302 plus 104 is 424. So therefore, the surface area is 424 centimeters squared. Now note, it's centimeters squared. You have to write the squared because this is an area, not a volume. Make sure your units are right. The markers like to see the right units. Your teachers as well. In your class assessments, if they give you surface area volume's not a hard topic. So they want you to get it right. They want everyone to get that topic right across every math curriculum. So try and make sure your units are right. In terms of the marking, if you use a net, you get 1 mark for the net with at least some values in it correct. If you are drawing the net this way and you calculate the 3 using Pythagoras theorem, you get a mark for that working. You can also do it by identifying that the height of the shape is 11. So they tell you here that this total height is 11 and that this is 8. So you can just get the 3 straight away from that. That would be a mark equivalent to using the Pythagoras theorem method. So these are both fine. And then the third mark will be for finding the surface area in terms of centimeters squared. So this question, not too bad. draw your net properly, right? Drawing a net when you're a high school student feels a bit silly because it feels like you're drawing shapes and then it feels like you're back in year 5 or 6, but it works, right? You want right answers, doesn't really matter how you get the right answers, so it's not silly because it works, right? So do these kinds of things because they make these questions much easier.